everybody. This is a few things you can do with lists. So I've done videos on NumPy arrays, pandas data frames. This one will cover lists, so not a special library, just general Python lists. So we're going to create a few lists here. One is going to be a number list. So you have a few numbers not in any particular order. And you have an alphabet list. Also a few letters not in a particular order. We're going to go ahead and kind of manipulate these and move these around. So one of the easiest things you can do is sort them. In sorting a list, you have a parameter called reverse. Reverse just says, do you want to sort it in ascending order or descending order, descending being reversed. You can actually leave this blank if you don't want it reversed. So I just showed it here just to give you an idea. But when you sort it using this dot sort notation, it's going to do it in line. What that means is you can't save it to a new variable. It doesn't return anything. It overwrites your list. So what we're going to do is go ahead and run that and print that. So we went from 1, 33, 15, 7, 9, 10, 11, 14 to 1, 7, 9, 10, 11, 14, 15, 33. If you want to actually reverse it, so again, going in descending order, you're going to go ahead and just put reverse equals true, and it goes ahead and reverses that for you. There's another way to sort things not using any list notation, and that's just using sorted. This is advantageous if you want to save it to another variable. So in this case, if I do it, I will sort it. Again, here you're going to actually input the thing you want sorted, and then you're going to select reverse equals false. Again, you can leave that blank by default. It is false, and you'll have the value sorted now in a new variable. So that's very useful if you actually want to return that. If you want to invert or reverse the list without sorting, meaning that I just want to take the list that's in the order that it's in, and I want to flip it around. So instead of having 1 as the first number, I want 14 as the first number. You can do this as a really long for loop and take a lot of time doing that, or you can use dot reverse. So we'll go ahead and regenerate that same values here. So we're going to reset the values essentially, and we'll do reverse, and you'll see that it does it again in line. So you're not outputting it to a variable, but it updates your current variable. And you see it starts now with 14, 11, 10. It goes in order that way. Another very useful thing that you can do in lists is count frequencies of certain items. So this is very useful for things like histograms and the like. So here I'm going to use the alphabet list. The alphabet list just being these letters here. And I want to see how many times the letter R appears. So all I need to do is put dot count, put the thing I want to count, and we look at it, and it will be number 2. It comes 2 times, right? FT, there's 2 R's right there. So there you go. You can also append things. So appending means that you're adding something onto the end. So it's very, very useful, especially in loops where you're going to have an output number and you want to add it to a certain list. So you just say numList.append, and we're going to append 55 to our num list here. So I'll go ahead and run that, and you'll see at the end of our list now we have number 55. That's all well and good, but let's say you don't want to add something to the end. You want to add something specifically to a certain area of the list, somewhere in the middle or at the beginning. Here we're going to use the insert function. Insert allows you to take the value you want to insert, which is the second input here, and input it at a specific index. So when I do that, you'll see at the first index, again, Python starts from the 0th index, you have the value 1001 added. Okay, so now let's go ahead and add another line, and I'm going to reset my values. There we go. So we're just going to rerun these so that we get new values. Let's say refresh lists, not values. Okay. Another thing you can do is extend the list. Extending the list is useful because it allows you to take another list and add it to the old list. The difference in using extend versus using append is if I appended a new list, what it would do, and I'll actually show you down here, what it would do is actually take that full list, but instead of adding each item individually to the list, it would add the list, the new list, as an item in the old list. So you'll see what I mean by that in just a second. But what we're going to do is have a new longer list, and we're going to take our alphabet list and extend it. So we have all our letters, and then it says new, longer list. Each item in this new list is now added to the old list. Let's go ahead and refresh our values again. And the other thing you can do is just click plus here. So this extend function functions just like adding two lists together. So if we have a new really long list, that's what we've done. So this is kind of handy because what this will allow you to do is save it to a variable so we can output it. This will update it in line as before. But now you have each item individually added to the list. And here, if I used, I'd mentioned, if I used the append option and added, let's say, alpha, beta, theta to my list, what you'll get is new, longer list, and then this item is a list in and of itself, notated by those square brackets. So that's kind of screwy. You have individual strings, and then you have a list of strings as the fourth item, right, in that list. So just to show you, if I access my new list at the, let's see, we have 0, 1, 2, third item, it's 3 items long, whereas the second item was 1 item long. So not something you would likely want in most cases. So let's go ahead and refresh our list here. My favorite thing you can do about lists is you can kind of do these inline for loops. And you're basically saying, print me out x squared for every x, for every value in my numbered list that's less than 50. That's what it's going to give me. So what I get is I'm going to square each value in my list. Any value that's under 50 is going to be squared, and it's going to print that out. So I have 1. So if we look at our list, where are we? 1 squared is 1. 33 squared, if I were to make a guess, is going to be 1089. 15 squared is 225. 7 squared is 49. 9 squared is 81. 10 squared is, where are we? 10 squared is 100. 11 squared is 121. And 14 squared is 196. If I change this from being under 55 to, let's say, being under 10, let's see how that changes. So now the only values that I've squared are 1, 7, and 9. Everything else is gone. So I can do a really quick for loop in that very directly. Another use for this would be something like pulling out all even numbers. So I'm going to say, give me x for every x. So give me an item, the item for every item that's in the number list. So I'm not changing it, just give it to me. If that number, when divided by 2, the remainder, that's modulo, so it gives me the remainder, is equal to 0. So if it's evenly divisible by 2, and it's going to print me out the even numbers. And there we go. We get 10 and 14. If we say, give me everything that's not equal to 0, this should be the odd numbers in that case. So we'll have 1, 33, 15, 9, or 7, 9, and 11. So these are a few things you can do with lists. I treat these as kind of the more typical things you can do with lists. I'm sure there's more detailed things you can do, which I'll unload in the future. But I hope this helps. I hope this gives you an idea of how you can use things and kind of expedites any kind of programming you're doing using lists.